guide for section 5.1 and 5.2. If you haven't written down the rules for exponents in your notes, you need to go ahead and do that. For multiply, you're going to add the exponents when you're dividing the same base. You're going to subtract the exponents when you're raising a power to a power, multiply the exponents. And with a negative exponent, it means division, and a zero exponent is 1. So write those down. We're going to use those while we're doing the problems. Also, I'd like to make a little note here on negative exponents. A rule you can use is a to any negative power is equal to 1 over a to the n. So notice right here the n is positive, where here it was negative. Okay. Another rule I hear people say sometimes is move to other side of the fraction bar. So if it was in the numerator with a negative exponent, you could put it in the denominator with a positive exponent. If it was in the denominator with a negative exponent, you could move it to the numerator with a positive. Okay, it works either way. Okay, I'm going to work the examples here. I will start with a, and this is multiplying the same base. The rule is add the exponents. 4 plus 2, it's going to be 3 to the 6th. X to the 5th times x to the 2nd, we are multiplying, add the exponents. 5 plus 2 is 7. This right here, this y by itself is y to the 1st. So we are multiplying the same base, add the exponents. 1 plus 3 plus 5 would be 9, y to the 9th power. This right here is multiplication, so we're going to add the exponents. Now, be aware that the z is the same base that we're multiplying here. Z to the 3rd times z to the 1st is z to the 4th, because I added the exponents. The 5 and the 7 are just coefficients. You just multiply them as usual. 5 times 7 is 35. Okay, on the next one, we've got t to the 5th times t to the 1st. It's going to be t to the 6th, because we add the exponents. Q to the 3rd times q to the 5th is q to the 8th, because we add the exponents. A negative 4.1 times 5 is coefficients. You just multiply them as usual. They're not exponents. 5 times negative 4.5 would be negative 20.5. If I can squeeze it in here. There we go. Alright, this one is rule 5. Anything to the 0 power is 1. So 5 to the 0 power is equal to 1. Negative 5 to the 0 would be, since 5 to the 0 is 1, it would be negative 1. 3x minus 8 all to the 0 power is 1. And if you have x to the 0 power, that would be 1, and 3 times 1 would be 3. Okay? I have another set of questions here. This one is division, so we're going to use the rule for dividing the same base, subtract the exponents. So 8 take away 3 is going to be 5. And normally the rule is if you are going from top to bottom, the answer will go on the top. If you were subtracting going from bottom to top and taking the top away from the bottom, the answer would go on the bottom. You'll see an example of that a little bit later. Anyway, 8 minus 3 is 5, so C the fifth. 9 minus 3 is 6, so 3 to the sixth. This one is dividing the same base. The base is x, so 7 minus 3 is x to the fourth. Now the 45 over 5 are just coefficients. You treat this as a regular fraction. 45 over 5 would be 9. Okay, on this next one, I have A that's the same base, B that's the same base, and then I have coefficients. Let's go ahead and take care of the coefficients. 24 over 18, you can divide both by 6. You get 4 over 3. Now the reason I extended this a little further, I don't know whether my A's or B's are going to be on top or on bottom, so I left myself some space. Okay, A to the 14th divided by A to the 7th. If you're dividing, we're subtracting the exponents. So 14 minus 7 is 7. B to the 6th divided by B to the 6th is B to the 0, because you subtract. And we learned earlier that anything to the 0 power is 1. Now I could put times 1 on here, but it's not really going to affect anything, so this right here would be the answer on that one. Negative exponent. Negative exponent means division. It means you can write it as the reciprocal. So this is going to equal to 1 over 6 to the second power. And if you know what the number is, you can go ahead and evaluate it. 6 to the second power is 36. Okay, we've got the same thing here. Negative 2 to the negative 6th power. That'd be 1 over, make sure you keep the negative 2 in the parentheses, 6th. And now if you want to do negative 2 times 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 negative 2, you can do that. I'm going to change colors to show that. Each pair of these will equal to 4. So I have 4 here. And I have 4 here. 4 times 4 is 16 times 4 is 64. So this would be 1 over 64. We have another set of questions here. This one is a negative exponent problem. The x has a negative exponent, so x to the fifth, negative fifth, is 1 over x to the fifth. If you times that by 3, it's equal to 3 over x to the fifth. So if you visualize this from the beginning, you could have just taken the x to the fifth and moved it to the bottom of the fraction bar. Okay, 5y to the negative 1. This whole thing is being raised to a power here. We have 5 to the negative 1 power and y to the negative 1 power. 5 to the negative 1 is 1 over 5. And y to the negative 1 is 1 over y, which turns out to be 1 over 5y. And I hope that kind of shows that if we had had a negative exponent on this whole thing, we could just move the whole thing to the bottom of the fraction. Alright, this one is a divide problem. And if you're dividing the same base, you subtract the exponents. 4 take away 11 is going to be negative 7. So this is k to the negative 7. But we don't like to leave our answers with a negative exponent. So this would be 1 over k to the 7th. Earlier I was talking about if you subtract from bottom to top, if you take the top out of the bottom, you would put the answer on the bottom. This is an example. If you had done 11 minus 4, you could have said k to the 7th on bottom. Another way of visualizing this is where are more of the k's at. There's more on bottom, so your result will be on bottom. Okay, on the next one we have 5 to the 3rd divided by 5 to the 5th. This is a divide problem. I'm going to subtract the exponents. I end up with 5 to the negative 2, because 3 minus 5 is negative 2. That's the same thing as 1 over 5 to the 2nd. Once again, we could have got this result from recognizing there was more 5s on the bottom and subtracting the exponents to get 5 to the 2nd on bottom. Because we know what 5 to the 2nd is, we need to go ahead and simplify this to 1 over 25. Okay, t. 5 to the negative 1 would be 1 over 5. 2 to the negative 2 would be 1 over 2 to the 2nd. Because we know the value of these, I can go ahead and 2 to the 2nd is 4. And then you add these two fractions together. Common denominator would be 20. You'd have to times this one by 4. So 4 times 1 is 4. You'd have to times this one here by 5. So 1 times 5 is 5. And if you have 4 20ths and add 5 20ths, that is 9 20ths. Right here we have a negative exponent again. Looks like a z to the negative 8 on bottom. Let's just move that to the other side of the fraction bar. We end up with z to the positive 8. Another way you can demonstrate that is 1 divided by 1 over z to the 8th. And if you are man, I don't know. No, that's yeah, that's right. If you divide fractions, you flip and multiply, which gives you z to the 8th. It's just easier to move it, change side.